So, welcome. This is the best picture I found of this canvas. This is just as introduction. Please let me start with a little video that perhaps some of you already knows.
I'm worried about little Dilbert. He's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute, and he disassembled the TV, our clock, and the stereo.
That's perfectly normal. Kids take things apart.
Oh. The part that worries me is he used the components to build a ham radio set.
Oh dear.
Is that bad?
Normally I'd want to run an EEG on him, but the machine isn't working. It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The knack?
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical and utter social ineptitude.
Can he lead a normal life?
No. He'll be an engineer. There.
So now, how many of you here students think that you are like him? Like little Lieber? No, you don't know? What do you think is an engineer actually? What's your idea? Feel free to say, there is no any wrong answers, whatever you think. I don't know. A nerd? What is it? What do you think? I'm going to do the presentation as well. I'm just asking you if you have any ideas. I don't want you to make the presentation. An expert in math? Sure, yeah. Chemistry, perhaps. Physics, this stuff. You wanted to say that, right?
Yeah.
Okay. But what do you think is a software engineer? Since here we are in computer science department. Don't you have any ideas? What?
Somebody who designs software.
Design software, yeah?
Develop software.
Are you an engineer? No. Just that? Well, the point is that software engineer, yes, design software. I want to focus our attention on the point that software engineers are not just coders. Coding is just one part of designing a software. So, mainly the best definition I would like to give for an engineer in general is problem solvers and lives improvers. And this is what we are understanding during the course with Professor Buckley. Problem solvers because, you know, there are always problems and engineers are required to use their background, their experience to build some solution. And then, in whatever job, when you build a product, a project, whatever, then the final result is to improve lives of people. And so, yes, they are designer, as you said. The typical situation is that you have a team, a problem, and you have to design a solution in a very short time. The customer is going to give you a time that typically can seem to be a bit short for what you have to develop. And do you know him? Mr. Albert said that we cannot solve our problems with the same thinking we used when we created them. In code, when you code, it happens that one day you code something, the day after, even if you've not changed anything, that code is not working anymore. And scientists cannot explain this point, but it happens. We don't know why. When you have to solve this problem, you need to change your mind. You have to be another person, and so you need to change your way of thinking. So what we need is creativity, curiosity, and imagination. If you don't have creativity, we are young, come on, we are students, and we are going to become young engineers, and we have to keep our curiosity, pose a lot of questions, because in this way we're going to train our brains to be really free and to build solutions. And we have to imagine a lot. We have to dream, actually. These are serious things. It seems to be something like Steve Jobs' presentation, these terms that are a bit theoretical, a dream, but it's true. If you don't have creativity, you cannot solve problems. And engineers are really asked to do these things. So let's talk about a dream. And since we are engineers, this dream is a curve, so inside a graph. This is an example of how to, let's say, manage a project. We have, in the first situation, we reason on specification of the problem, we make some analysis, then we start designing. After all these things, we start coding, then we make the integration, because there are teams, so several parts that has to be integrated all together. Then we make some testing on what we've realized, hoping that we don't have a lot of errors. And then we can give our product, and perhaps some maintenance is needed. So this is a dream curve, because if we give a lot of time, we spend a lot of time in doing the specification in a good way, then all the other steps will need less time. And if everything is perfect, you don't even need to do any maintenance, because it works. But this is a dream. This is reality. And this is the difference between normal coders, let's say, and software engineers. Because at the beginning you think, yes, okay, come on, specification, the problem is known, I have to solve this, and that's it. I do some little analysis, the design doesn't require much time, and then you start coding. But anybody of you code, have some little experience, you know, you can start coding whatever, then perhaps, and so you implement some ideas, then you think that you have to change something. Perhaps what you realized before is connected to this new change you want to do. And if you want to make this change, you need to change everything you've done before. And this will take a lot of time. Now, I'm not talking about a simple Android app. Let's think about a big software. Like, I don't know, Microsoft Office, the software Word, Excel. If something is wrong and you have to change the code, you have thousands of lines of code that you've coded before. Many people worked on that before you. So it will take a lot of time, and so it will be very difficult to make integration of all the parts. And then the testing will bring to a lot of problems or mistakes, errors perhaps. And that's why then you need a lot of maintenance. So the suggestion is think before coding. Just don't start to code, and talk before coding. When we are a team, this is what we are experiencing during this course, we are a team. If you talk, you are forced to clarify your own ideas, and also the other members of the team are going to understand your ideas. Perhaps they don't agree, or they agree, you can discuss about it, and so you come up to a very great solution, and after that you start designing something, and then you code it. And so, design before coding. You know what is Socially Relevant Computing Center? Have you ever heard about this? How many? Just raise the hand. How many?
If you go to school here, you will.
How many? One? Okay, this is the problem. This is our problems for our project. Nobody knows who is this center. And this is a very bad thing for us. Because, you know, what is it? We don't know. I prepared some picture. Well, who are you? Can you see what's happening in this picture? Okay, this is the first presentation. You're a bit still sleeping. You don't want to interact at all? What do you see here? People? People what?
People helping people.
People helping people, yeah. There are some disabled actually, and there is some pieces of technology. So here, in this center, Socially Relevant Computing Center, engineers, students, people are working with technology, building some solution for improved lives. And I will give you some example later. These are some examples of technology used and realized. These are some examples. They build systems that use lights and sounds and other sensory input to teach choice making and other skills to disabled children. You know, lives actually is communication. If you're not able to communicate with your parents, your friends, whatever, you're alone. This is not life. So there are people who have some limitation in normal, what we consider the standard communication, because there are many ways for communicating. But thanks to these projects, people obtain some new capabilities that perhaps they didn't have. But these are just some examples. Then we have wireless networking device for emergency response personnel like firefighters, allowing them to work more safely in dangerous situations. So there can be other situations, other jobs that will use this kind of technologies. And all these stuff are going to be realized inside this lab, but nobody know about that. And I personally think that is one of the most interesting things that are done inside this campus. But even inside the campus, nobody knows about that. Just in computer science, so this floor of Davis Hall, some people knows about it.
You're making me feel bad about my lab.
The lab is good, but you know,
No.
what we are going to do is to solve this problem. So our customer is the social related computing lab, who's asking us to improve his presence. He should be a bit more famous, but not because he wants to be famous, but thinks.
No, I want to be famous.
Okay, and famous as well. But the point is that if more people know about that, more people can contribute to that. And it's nice to see that there are people working on these projects. So, lives improvers. We are going to improve lives of workers inside the lab, and at the same time, if we improve those lives, we are also improving lives of the final user of the products realized inside that lab. So we're going to improve the web presence, fundraising, and HR. So finding some resources, human resources, to improve, to give some help to these projects. For example, social networks. We thought we started by designing, not just coding. If we have started just coding, we would have just realized a new website. But actually, it's not really solving the problem, because there already exists a website. It can just be fixed with a more, let's say, a cooler interface. But this is not enough, so we start designing, thinking of a solution, and we thought that web presence is not only a website. Nowadays, we have a lot of social networks. Yeah. So social is one of the solutions. Then also a dynamic website, a platform that I'm going to explain you in the next and last slide.
Lucas, we only have 2 more minutes, unfortunately.
Yeah.
So you have to wrap it up.
Yeah. So Adobe Tools, and this is the last slide. The next is last slide.
Good.
And Adobe Tools thinks of Google Drive, Google Doc. All these tools are useful for working, but in some places where the work is very specific, like this lab, some Adobe tools can be very useful. And so synthesize everything in a mobile app, such that users, workers of this lab, can check their work inside their mobile devices, wherever they are. I said platform because it's a set of a lot of things. This is the solution we are going to implement. Kickstarter style to make some fundraising, but in an easy way inside this website. Code sharing such that people don't need to stay inside the lab. Even if they're traveling, they are somewhere else. They cannot go to the lab. They can still, like GitHub, I don't know if you know it. It's like a platform where you can share codes, ideas, sketches, and so in this way the lab work is more productive. Then easy access for disabled people, because they can work as well on this website. Some about the project
Why don't we
area.
do it for questions now?
Sorry?
If that's okay.
It's finished.
Okay, join the
And then I
questions.
join the project section. So this is the shall be relevant. Is our solution.
Lucas did a great job of explaining what it is the students in the lab do. And all the students in their last year have to. And so they have to go through this lab, they have to